Hello, good morning, my student. This is Ismail here. Okay, today we're going to start third lesson, Integrate Math 2, and 1.3 inverses of a function. You can always find the lesson using my website, www.alfaramath.com. Okay, now today we're going to start the inverse of a function. First, let's have the essential question. What is inverse function and how do you know it's an inverse function? Okay. Now, this warm-up questions, you can pause and solve this warm-up question. It's from the previous question. Okay. Now let's start for some definitions. Okay. So this is basic definition. We already know them, but let's go through. So a relation is a set of ordered pairs or anything that can be represented as an ordered pair. So as you can see, so like 2, 4, or 6, 3. So all of these are ordered pairs. So number two, as you can see here, the elements of the domain always related to the x-axis, and we call input. The element of a range is related to the y-axis, which is called the output. Okay, number four is the function. We know that the function is a special type relation that pairs every input with exactly one output. Okay, so a function, we know that the function, the example, let's say 2x plus 3. So this is the function. So pairs every input because we sort of replace them here, okay, with exactly one put output. So when we replace x here, we will get one output. Okay. Now, this means that an x value can never repeat, okay? X value can never repeat, okay? Giving a different y value, but the same y value can come from two different value of x. Okay, what does that mean? Let's have a look on this example. So for example, let's say we have this function here. So this is a function. So as you can see here, we know that this is x, this is y, x, y, x, y. And the x, okay, we know that the x1 or the x side is always represent the domain. So that's mean if I ask you, let's write the domain here on the other side. So here we have domain number one, okay? And in the second point, domain also number one. I don't need to repeat number one twice. Okay, here the domain is number two. So now we have domain, okay, which is one and two. Now let's do the range. So as you can see the range here, we have number two, number four, number six. So as you can see, two, four, six. All of these are the range. And now let's connect between them. So number one, it's related to the number two. Okay. Number one here again is related to the number four. So number one is to the number four again. Number two is related to the number six. So two to the number six. So as you can see here, we have the domain and the range. So if we complete, it's not a function. Why it's not a function? Always, 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 when we have one domain related to the two outputs, of which is two range, so it's always not a function, okay? But in the other side, let's have a look on the second example, which is this one here, okay? This function here. So this function here, let's write the domain for it. So which is, it will be, okay, so the domain is 4, negative 5, and 7. 4, negative 5, and 7. And the range is 3, 3, 2. So 3 is repeated twice, so one times. So now let's check. So 4 was a 3, okay, and negative 5 also with a 3, and 7 with 2. See, look here. So 4, it's connected with one output. The negative 5 is connected with one output. The 7 is connected with one output. So every input is connected with one output. So this one is a function. It doesn't matter if the domain, or let's say if the range repeated it twice. So this is what we explained here. So it doesn't matter if the y repeated. The important thing is the domain never repeat twice. Now, if I ask you about this one here, how about this? So this one 6, negative 2, 8, negative 1 over 4. So this one is a function. Okay, now let's go next. Okay, now here we have two type of the function. Okay, we have two type of a function. The function has a two type. The first one is 1 to 1. Okay, the second one is many to 1. Okay. So what's the difference between many to one to one? So one to one, if we have an example, one, two, three, and the other group, which is let's example four, five, six. So for one with four, two with five, five with three with six. If we have many to one, so that's mean we have one, two, three. So let's say we have four and five only. So one related to the four, two to the four, and three to the five. So this is many to one. Okay, so both of these and this one is a function because one domain has one range. Each input has one output. Okay, so how about the inverse relation, which is the inverse of function? So as we can see here, the inverse of function, if inverse of a function of x is also a function, it is called inverse of a function and is written f to the power negative 1. So as you can see here, the function is always f x. The inverse of this, if it's written as to the power negative 1 to the x. Okay, so we now produce the inverse of the function with negative 1 in the power. Now let's take this example here. Okay, now the mapping diagram shows a function. So as you can see, we have this function. So this function is negative 4 to 2. Now let's write the inverse. So the inverse, just switch between the domain and the range. Okay, so it will be negative 2, negative 4, negative 3, 2, 1, and here 0, 1, and sorry, 0, 1, and 4. Okay, 1 and 4. Now, let's answer on the first question. Is the function one to one or many to one? Explain. So as you can see here, this function, because every input, okay, every input from here, okay, has one output. Okay, so that's mean this one is one to one function, okay, because no output is ever used once. Number two, okay, the mapping above, okay, of the function is the inverse of a function. So as you can see here, this one is the inverse of the function. And explain. Yes, so as you can see here, the inverse is a function because each input has one output. Let's take this example here. So now in this example, let's complete the mapping. Okay, so as you can see here, negative 3 with the 0 and 2 is with 1. Now let's see the first question. The first question it's saying, is the function one to one or many to one? Explain. So now as you can see here in the function, this is many to one because 1 is going to 2 and 4 goes for 2. So this one is many to one because number 2 here in the range has 2 domain. Okay, it's okay if we have a range 2 domain, but it's not okay if we have one domain with 2 range. Okay, now is the inverse of a function is also a function? Is now this one a function or not a function? So if we check now every input with one output, so negative 2, negative 4, negative 3, 0, 2 with 1 and 2 with 4. So 2 is repeated twice. So the domain now is repeated. So this one is not a function because the input 2 has two different outputs, which is 1 and 4. Now this is your turn. Pause the video. Try to solve them by yourself. Okay. Now let's continue to the second part. So as you can see here, let's do some explanation about this. So the graph of the original function in section B is shown. Note that the graph on the red is the line yx. Write the inverse of the function as a set or order pair and graph them. So as you can see, we have the function represented by this. So this is my function, which is in the black dots. Okay, the black dots is my function. So now let's find the inverse of the function. So the inverse for negative 4, negative 2. So for sure it's negative 2 and 4. 0, negative 3, it will be negative 3 and 0. 1 and 2, it will be 2 and 1. 4 and 1, it will be 1 and 4. Okay, now if we plot these points on the coordinates, okay, so let's plot them. So negative 2 and 4, it should be here. So this is the first point. Negative 3 and 0, negative 3 and 0, so it will stay here. 2 and 1, 2 and 1, so it will be here. The last one is 1 and 4, 1 and 4, so it will be here. Now, if we look at the points, okay, so if we look at the points, okay, so as you can see, all the points are reflected like a mirror. So if you look here, all the distance between the points are reflected. And let's answer on the second questions. What do you observe about the graph of the function and its inverse in relationship to the line y equal x? Why does this make sense? Now, the graph are reflection across the line y equal x. Okay, that's right. They are mirror image of each other, with the mirror being line y equal x. Okay, now this is your turn. Try to do this two question by yourself. Pause the video and do it. Okay, now let's go to the composition of a function. Okay, let's leave this one later. I will go back to this one because maybe it will confuse you if I do it now. Let's go here now for this. Now, how we can find the inverse of any linear function? So as you can see here, step to finding the inverse of linear function, we know that this is the linear equation. So you know that the linear equation is y equal mx plus b, right? Okay, it's similar to f of x because y it's f of x. Now, first, interchange the x and y. Okay, solve for new y. Replace y with this one to check show that this one and this one. Okay, now let's start with the first question here. So as you can see here, find the inverse function, which is f to the power negative 1x. For the given function f of x, use the composition to verify, okay, that the functions are inverses. Then graph the function and its inverse. Okay, now first step, we need to replace f of x with y. So now let's replace f of x with y. So y 2x minus 2, right? So now this function solve for, okay, for x, which means we need to isolate x and we need to find x. So now how we can solve for x? First, let's add plus 2 for both sides, plus 2 plus 2. Okay, so it will be y plus 2 equal to x. Then what we need to do, now let's divide by 2. So divide by 2, divide by 2, divide by 2. So now this 2 will go with this 2. So now x is equal, okay, 2 over 2 equal 1, y over plus y over 2. So if we rephrase this one, so it will become x equal half y plus 1, because y over 2, is it similar if I write it 1 over 2y? Yes. So y 1 over 2, so that is my inverse. Now what we need to do, just switch switch between y and x. So put y here and x here, just switch between them. So it will be y equal 1 over 2 x plus 1. So this one now is my inverse function, and we can write it as like this. So let's change y to become f of negative 1, x equal 1 over 2 x plus 1. Okay, so that's how we can find the inverse of the function. Okay, I will come later for the check. Now let's continue. Let's take another example. Okay. Oh, sorry. Then group and its inverse. Okay, let's graph them. Let's try to graph them. Okay, let's graph them. So let's graph first my original function, this one here. So let's make graph here. So as you can see, the slope is 2 over 1, and the y-intercept is negative 2. So negative 2 is the y-intercept, okay? And 2 step up and 1 to the right. So my graph will be like this, okay? This is my first function, okay? And my second function, which is the inverse, let's find it. Okay, the stuff for the inverse is 1 over 2, and the y-intercept b is equal 1. So b is equal 1, which is here, okay? Which, and 1 rise over 1, okay? Rise over 1, know it. Okay, rise over run, which is 1 step up, 2 step to the right. So my function will be here. So now if we connect between them, so as you can see here, my two functions look like this one here. Okay, I will go back to the check, verify later, don't worry. Now let's take this example here. Okay, after we know them, okay, first step, we convert f of x to y equal to 3x plus 4. Now we need to solve, okay, for x. Okay, solve for x. So now to solve for x, we now need to minus 4 for both sides. So it will be y minus 4 equal to 3x after we cancel this. Then let's divide by 3, divide by 3, divide by 3. So we cancel this. So now x, okay, x is equal y over 3 minus 4 over 3. Can we rewrite this one? Yes, so it will be x equal 1 over 3 y minus 4 over 3. Okay, now let's switch. Okay, let's switch between x and y. So it will be y equal 1 over 3 x minus 4 over 3. Okay, so now let's write this one as inverse. So it will be f of negative 1 x equal 1 over 3 x minus 4 over 3. Now let's graph this both function. So this is my first function. So my slope, it's equal to 3 over 1. B is equal to 4. Okay, so now B is equal to 4, which is here. 3 steps up, okay, and 1 step to the right. Or we can go 3 steps to the left, to down, and 1 step to the left. 1, 2, 3, and 1 to the left. So my graph will look like this. Okay, so this one is my graph. Now let's graph the other one, which is here. So my slope, it's 1 over 3. Okay. B is negative 4 over 3. Okay. So negative 4 over 3. Negative 4 over 3 means 0. Wait. No, 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 no. Sorry, sorry, sorry. Okay. Now let's divide. Okay. Let's divide 4 over 3, okay, which is 1.3, right? So it will be negative 1.3, so it will be somewhere here, right? So this is my first point. So now let's go 4 step down. So it will be 1, 2, 3, 4 down, and 3 steps to the right, 1, 2, 3. So my point, it will be somewhere here. So if we connect between my points, it will be something like this. Okay. Now this is how we can check this one. Okay, these are 2 questions. Try to solve them by yourself. But now let me back to check and verify. Okay, what's the check and verify? Okay, check and verify. Now I have 2 equations. I have the normal equation and I have this equation here. Okay, now let's put them together. So if we have f of x equal 2x negative 2, and the inverse of this function is negative 1, x equal 2, sorry, not 2, sorry, 1 over 2x plus 1. So now, as you can see here, we have 2 equations. What we need to do to verify, we need to may put this one, replace it with the x here, okay? So, or which is we are going to replace it with the x. So my function, it will be f of if the inverse 1x, okay, is equal. Now 2 times half x plus 1. So this one will be the x for this function. So I replace it in the x here. So then I need to solve it. So to solve this one, use distributive property. Use distributive property. So it will be 2 times half equal 1x, and 2 times 1 equal, okay, equal 2, then minus 2. Minus 2 with plus 2 equal 1x. So my answer is 1x. Now let's try the second one. Okay, so the second one here, we will now change. Now we will take this one and replace it in the x here, which means we need to put it here. Okay, so now f of inverse, okay, f of x, okay, so that's mean I need to put this one in the x here, okay, which is replace it here. So it will be f of this one. So 1 over 2, okay, 2x minus 2, okay, plus 1. Now let's use the distributive property, okay, equal half times 2 equal 1x, and half times negative 2 equal negative 1 with a plus 1. So now this one will cancel this one. So my answer is negative. So is my answer is 1x. And because I have 1x, okay, is equal to 1x. So that's mean my inverse function that I find here is correct. Okay, so that's me check and verify. Let's do the second one here. Okay, so I just need to save the time. Okay, now let's check from the answer here. So let's put them together. Let me remove this one. So as you can see here, my function is 3x plus 4. Let's replace it, which it will be 3x plus 4 minus 4 over 3. Then we replace, simplify this. We get x and x, which is the correct answer. Okay? X is equal x. So that's what I was explained here, which is the composition of function. Composition of function, we are inserting a function inside a function, means f of x and g of x. So this is a function, this is another function, written as f of g of x. So we can read it f of g of x is a new function that uses output of g of x as the input of x. Okay, so we use it like this: f of g of x. That's mean we use the g of x. Okay, it will be the input, okay, for the x. So anything that I find from g of x, it will be the x of the new function. Okay, I hope you understand that. Okay, here are two questions to you. Now, so pause the video and try to solve them by yourself. Have a good day. Bye bye.